Hello everybody. I think you all must have seen my previous videos where I have discussed all the other sorting algorithms. So this algorithm is the last from my list of sorting algorithms. It is the merge sort algorithm, and as I have already described how a divide and conquer approach follows when I was teaching about the quick sort algorithm. You have to understand that the same approach, the same technique is being followed in the merge sort algorithm also, but there is a change in the basic algorithm. It does follow the divide and conquer approach, but the algorithm is slightly different. So come on, let's see how this works.
Come on, let's look at the merge sort algorithm. See, I have already told you that merge sort algorithm is primarily based on the divide and conquer approach. We have already seen this approach being used in the quick sort algorithm. Similar to that only, you'll see that how divide and conquer is used to sort the elements of an array or of a list either in ascending or descending order using merge sort. So now what happens in merge sort is you first want to divide the given array into say two smaller lists. So let's say for example, since this is of size 9, the array is of size 9, so we are going to divide it from here, from the center. So this forms now two lists. So the two lists will be like this. After this, we are going to continue the process of breaking the arrays. So after this step, what happens? We divide the array across this. So this particular list now gets broken up into further smaller pieces like this and this. Similarly, you will break this into further smaller lists. So it will be like this. Now this breaking up of the list will continue till you only have single elements in each list. Say for example, you break it up like this from here. So this will become 15 and 5. Here we'll only have element 24. If you further break up this list, this is going to become 8 and this is going to become 1. If you break up this list, you are going to have two single elements, 3 and 16. Breaking up of this list will give two elements, two single elements, which are 10 and 20, like this. Now this has to be further broken up, and because the breaking of the list should take place until we have single elements as lists, individual lists. So now after this has been done, what will happen? We are going to merge them back to form the sorted array. So first of all, merging of these two elements will take place. And when you merge, you have to be careful that you must arrange it either in ascending or descending order as per whatever output you want. If you want to have a ascending sorted array, a sorted array which is having the ascending order, then you must also join them back in the ascending order. So when we join these back, my array will be like this. We have joined them in the ascending order. Then we are going to join 24 with this. So you will see where this 24 actually lie. If this number would have been say 12 instead of 24, then you must have put 12 here. but since it is not and it's greater than 15, therefore we will merge it here. When you join back these two and arrange them in the ascending order, you are going to get a list back like this. Similarly, joining back these two will make your list now like this. Joining back these two will result into a list like this. Okay. Now we are going to join them back again. So when we join these two, what are we going to get? See, we have to now arrange it. Now just try to understand what algorithm is working in the background. Say for example, we say that this is array A and this one is array B. Okay. So we might take index I, variable I to index array A, and say we are taking variable J to index array B. And then we are going to have a third array after the joining. So all these joinings, say here, here, everywhere, it was done in the same manner. So let's say after joining we want to store it in array C and it is indexed with variable K. So now how it is going to behave? How are we going to write the algorithm? Pay attention here. Basically we are going to compare A of I and B of J. So my algorithm would say that if A of I is less than B of J, okay, then C of K equals to A of I. So you are basically putting the smaller among these two into C of K. And one more thing you have to remember, that you are initializing I with 0 here, J with 0 here and K with 0 here. Okay. So you are basically here for the first iteration. At the first iteration, your A is 0, B is 0, K is 0. So you are comparing A of 0 with B of 0 and putting the smaller one into C of 0. See, my C array is also like this, correct? So you are basically comparing these two and you are putting the smaller one here. So which one are we going to put here? We are going to put 1 here. Okay. Now after this what happens? We are going to do an increment of K and increment of I. Since we are putting, see, if you look at this code, we are putting A of I because A of I is smaller than B of J. So the one that you are putting into the array C, you are going to increment that along with the index of C array. And if not this, means if this condition is not true, then in the else part, that means B of J is smaller than A of I, which was the case here. The case we saw here, we are writing about that in the else part. So else part, what does it say? That B of J is smaller than A of I. If that happens, then instead of A of I, we are going to put B of J into C of K and do a K plus plus and J plus plus here. Okay, I hope you have understood how we have done. Let's see again. So from, okay, now that you have the algorithm here with you, so sorry about this. Okay, so how this merging of single elements here, how this merging took place, that we are seeing with the help of this particular algorithm. Okay, so here see, now your currently your I is 0, J is 0 and K is 0. So I am saying I am comparing A of 0 with B of 0. That means I am comparing this with this and putting the smaller one into C of 0. So smaller one here was the one in the B array. So after I have put this, I am going to increment j and I am going to increment k. So now my k becomes 1 and j becomes 1. So next I am going to compare a of 0 with b of 1, this element. Now my a of 0 is less than this element 8. So I will be putting value 5 here. Okay, now since I have put the value from the array A, so I am now going to increment I and k will be incremented. So now my next elements for comparison, since there is no other element. Okay, now B I haven't put here, correct. So my next elements for comparison are A of 1 and B of 1. Okay, now among these two, the B array 1 is smaller, 8 is smaller than 15. So I am going to put 8 here. Okay, and now you can see that we have exhausted array B. Understood? We have exhausted array B. So what we are going to do here is, once you exhaust any one of the two lists, then the other list which is not exhausted and remaining, the other array, you are simply going to put its element into the array C like this. Now just check, do you have a sorted list here? Yes. I hope this particular algorithm is clear to you. This is important. This particular algorithm is clear to you guys. I'll just erase it because I need to show you the merging of the other parts also. Okay, so after this, the merging of these two lists will also take place. Okay, we are going to merge these, and we know how we are going to sort and merge these. We have already seen it. And finally, we will be merging these two lists to form our final output list. See, here also, while merging, will follow the same process. First, we are going to compare this and this. This one is smaller, so I am putting 1 here. Remaining, so my j is here, my I comes here, k is definitely here, it has incremented. Then I compare 5 and 3. 3 is smaller, I put it here. Now my j points towards this element. Compare 5 and 10. I am going to put 5 here and I will increment I. After I put I here, I am now going to compare 8 and 10. 8 is smaller, I am going to put it here. Then my I gets incremented, my j is still at 10. I'm going to compare 15 and 10. 10 is smaller, we will put it here. Then my j is now incremented to this element, my I is still at 15. I'm going to compare 15 and 16. 15 is smaller, I will put it here and increment the value of I. So now my a of I is pointing towards 24. J is at 16. So I compare these two values to put 16 here since it is smaller. And then finally I compare 24 and 20. 20 is smaller, I put 20 here. One list of mine gets exhausted. So I'll just put up the remaining elements from the other list which is not yet exhausted into the final array, the merged one. So this is how basically merge sort works. As you can see, there is division and joining, division of the originally given array into two parts. Every time it is getting divided into 2, 2, 2. And that is happening till we get single elements in the list. So basically the division is happening for every element till we get that element as a single element into the list. So for all the cases, see, be it best case or the average case or the worst case, the time complexity will be big O of n log n. Okay, the time complexity is going to be big O of n log n, because be it the best case, what will be the best case? That we are having an already sorted array. Say I have an already sorted array like this. Now if we are going to use merge sort in this, you are going to follow all these steps. You are going to divide it into the arrays until you get lists of single elements, further divided into two lists. Okay, 4 and 5 here. These two will be further divided into single elements. Then we are going to merge this. Okay, so the process is going to stay same. For every element we are going to take log n steps. We are going to perform log n steps. Be it the best case where the array is already sorted, be it the worst case where I have a reverse sorted array, still the procedure remains same. Okay, in the next video we'll discuss about the pros and cons of merge sort algorithm. Along with that, I'll explain two other terms which are important when we are talking of the sorting algorithms. They are about which algorithms we call as in place sorting algorithms, and some algorithms we call them as the stable algorithms. So what does these terms mean? We'll look into the next video. Thank you.